Alrighty, so in this video, we are going to be integrating and deriving power series. And essentially, it's going to be the same thing that we've been doing in terms of AB material back in Unit 2 and Unit 4, where we're just going to be using the regular power rule and the regular anti-power rule in terms of these power series. So here we have f of x, we have a series, a power series, and we're going to be focusing on the x minus c part, because that's my variable part. Now with my variable part, I am going to use the regular power rule to find my derivative of it. So in this case, my derivative is going to be n times a sub n times x minus c to the n minus 1. So you can see that I'm bringing down my degree as a coefficient, and then I'm subtracting my degree by 1 to get my derivative. Likewise, to find my antiderivative, I'm going to up my power and divide. So now I have x minus c to the n plus 1. And then, of course, because I have an n plus 1 as an exponent, I'm going to divide that. So now I have 1 over n plus 1. And, of course, you have your regular lovely plus c going on. All right, the radius of convergence obtained by differentiating or integrating is always going to be the same. The only thing that's going to be different is going to be your interval of convergence. And that's going to be a little bit different depending on my endpoints. So our focus whenever we are finding the interval of convergence is going to be using the same interval of convergence for f of x, but then testing the endpoint to see if f prime of x and the integral of f of x have different endpoints per se, whenever we are testing for convergence. All right, so 1a, we are given f of x is equal to the series negative 1 to the n plus 1 times x minus 2 to the n over n. And we are given that the interval of convergence is between 1 and 3. We want to find f prime of x and its interval of convergence. So to find f prime of x, this is just going to be easy peasy lemon squeezy, because we're only going to be looking at my variable x and then taking the derivative of that. Everything else stays the same. So here we are going to get negative 1 n plus 1 times n minus 2 to the n minus 1 all over n. Now, if I were to simplify that, that is going to be the same thing as negative 1 to the n plus 1 times n minus 2 to the n minus 1. And what we're going to do with that is go ahead and plug in a 1 and plug in 3 to find my new interval of convergence based off of f prime of x. So if I were to plug in 1, I get negative 1 to the n plus 1 times negative 1 to the n minus 1. And if I were to do that, I am going to get negative 1 to the 2n, which is essentially the same thing as 1 to the n, and 1 to the n, well, that right here just diverges. Sad. We're going to do the same thing for positive 3. So now I have negative 1 to the n plus 1, and then 3 minus 2 is 1, like that. All right, well, 1 to the any power is just going to be 1, so I'm only going to be focusing on this right here, negative 1 to the n plus 1. I'm going to go ahead and break this down so that I have negative 1 to the n, and then negative 1 to the 1, which is just negative 1. Well, let me write that as a third stop. All right, we have negative and then negative 1 to the n, and unfortunately this one also diverges. So since both of them diverges, this tells us that my interval of convergence is going to be from 1 to 3, but we are not going to be including 1, and we're not going to be including 3. All right, 1b says, using the same function from above, we are going to find the integral of f of x dx and its interval of convergence. So what we're going to do is go ahead and take the antiderivative of this. Remember that we're only going to be focusing on this part right here. So I have, let's see, 1, -1 to the n plus 1. I'm going to up my power, so that's going to be x minus 2 to the n plus 1. And then I'm going to divide. So now I have n plus 1 and then n. We are going to be testing 1 and 3 for my interval of convergence. So I'm going to plug in x is equal to 1. And that simplifies down to, we said earlier, this is just going to be 1. So 1 over n plus 1 n. This looks like a telescoping series because we're going to be using partial fractions eventually. So this right here will converge. Now at 3, we have -1 to the n plus 1. 3 minus 2 is 1. Over n, and then n plus 1. All right, remember that 1 to the any power is just going to be 1, so that's just going to be me looking at this series right here. This is going to be an alternating series, so what we got to figure out is see, are my terms decreasing? And we know that they are. And then we also need to figure out my limit. And see if this is 0, which it is. Since that's the case for both conditions, that it's decreasing and my limit approaches 0, we know that x is equal to 3 converges by the alternating series test. So we know that my interval of convergence is going to be including 1 and 3. So that's that. All right. Let's look at number 3. We have a power series f of x is equal to the series from 1 to infinity of -1 to the n plus 1 times x minus 3 to the n over n times 3 to the n. And this is a Taylor series centered at c is equal to 3 for a certain function f. Part A says find the first 3 non-zero terms and the general term for the Taylor series for f prime of x, aka the derivative of f, centered at c is equal to 3. Okay, so we are going to go ahead and take the derivative. Remember, when taking the derivative, we're only going to be focusing on the variable x and nothing else. I'm going to simplify this a little bit. And what we just found is the general term. this right here is my general term. We will eventually rewrite this again because we want to find the first non-3-zero terms. So we're going to look at n is equal to 1 and see where that takes us, and then 2, and then 3, and then see where that is. So if I were to plug in 1 for n, I'm going to get -1 square x minus 3 to the 0 over 3 to the 1. Well, we know that x minus 3 to the 0 is just 1, and then we know that -1 squared is just 1. So this right here, my first term, is going to be 1/3. Okay, now using the same process, my second term is going to be -1, and then 2 plus 1, which is 3, x minus 3, 1, and then 3 to the n. So in this case, this is my second term. Now, -1 to the third power is going to be a minus sign. So now I have minus x minus 3 to the first power, and then over 3 squared. So that's my second term. My third term is going to be -1 to the fourth, x minus 3 to the second, and then 3 to the third power. -1 to the fourth is going to be a positive number, so that's positive. And then I have x minus 3 to the second power, and then 3 to the third power. So this is my first, this is my second, this is my third, and then, of course, you kind of want your general term somewhere along the first 3 non-zero terms. So this right here gives us my first 3 terms and my general term. All right. Now, based off of this information, Part B says, use the fact that the Taylor series for f prime of x is geometric to show that over its interval of convergence, f prime of x is equal to 1 over x. Remember that the series is going to be the sum of all the terms. So in this case, if I were to add everything up, this tells me that f prime of x is going to be equal to 1 over x. And remember that since this is geometric, remember that the geometric sum formula is a over 1 minus r. Okay, so we already know that a is 1/3 based off of my first term right here. The only thing that I'm worried about is now what my common ratio is. Now going from this term to probably this term right here, you'll notice that my common ratio is going to be negative x minus 3 and then over 3. Because you can see that I'm multiplying x minus 3 each time in the numerator, and then I'm multiplying by 3 each time in the denominator. So now I have 1/3, 1 minus this right here, so technically 1 plus x minus 3 over 3. We're going to have to simplify this because we want to show that this eventually will become 1 over x. So I have 1/3, and then I'm going to have 3 over 3 plus x minus 3. So now I have 1/3 x over 3, which is essentially the same thing as 1 over x. Yay! So that was number 3.